right, so now we're going to start talking about geometric sequences. And when something grows geometrically, it grows exponentially. If you notice, there's an exponent in this formula where the n is in the exponent, because typically if something is a growth, it's going to go like a rocket ship like this, okay? And like cells in a petri dish grow geometrically. One cell becomes 2, 2 cells become 4, 4 become 8, and before you know it, you've got a pandemic, okay? So when you think of it that way, that was geometric growth. And I was watching it at the beginning, and at the beginning it wasn't, the rate was not that high, so it was going slow, but once it took off, the rate changed and it went crazy. That's when everybody started getting sick. Straight up. So when we have a geometric series like this number 1, we have -1, -3, -9, -27, ... To find, in this case, we don't have a d anymore. D would be the distance between terms that we did last time. And if you notice, it's negative. If we were looking for d, it would be -2 on the first two, and then -6 on the second two, and -18 on the third two, right? So it's not an arithmetic series. The thing is getting very big very quickly, okay? Or very small very quickly in this case. So to find r, you take any term and you divide it by the one before it, okay? So what is -3 divided by -1? So your r is 3. Everybody get that?
You can use any.
In a geometric series, instead of adding to get the next term, you're multiplying, okay? If the number happens to be a fraction that you're multiplying by, you're still multiplying. Don't look at it as dividing by 3. Look at it as multiplying by 1/3, if it happens to be a fraction, okay? When r is a fraction, the numbers get very small very quickly. When r is a positive or negative, they either get big or small, depending on if it's positive or negative, okay? So if I need to find, first you need to find the common ratio. That's your first question. Then you need to find A10. So to find A10, we do A1 times r to the n minus 1. So A1 is -1 times 3 to the 10 minus 1. Everybody see that?
Where did it tell you?
So it's going to be -1 times 3 to the 9. That gives us -19,683 is A10. And that's your second. That's your second answer. So you've got 2 answers for each of those. All right, so this is pretty easy because our formula is AN equals A1 times r to the n minus 1. So A10 equals -2 times 4 to the 9, which is 10 minus 1. You see what I did? I already subtract the 1. These tend to be big numbers because we're multiplying by 4 each time. So the growth, it should be that. Make sure you get that answer.